All right, so that was a very good point. I needed to add symbols to the picture, so first you know it's a parallelogram. You could not solve this if you did not know it was a parallelogram. So go ahead and solve for x and then plug it in to find the measure of angle BCD. This form-up is not very enlightening or exciting, but it's a basic application of the parallelogram properties. Wow, y'all are quick. 38 and 102. 38 for x and 102 for the angle. Does anyone want to argue? So what did you do with these two angles? Hopefully you knew that consecutive angles were supplementary. Consecutive angles are supplementary. And so 3x minus 12 plus x plus 40 equals 180 is hopefully how you set that up instead of accidentally setting them equal, because they are not. Opposite angles are congruent. Okay. Answers to the homework that was called Proving Parallelograms. Proving Parallelograms answers. All right, number 7. What are the directions on this section? State whether or not you can conclude that it is a parallelogram based on the information given. If yes, state the theorem or definition that justifies your conclusion. Pretty sure we did this one in class yesterday. RU is congruent to UT, which is congruent to TS, which is congruent to SR. So that would mean that all sides of this figure are congruent. So I would absolutely say yes. And what theorem justifies it? Both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. Is RS congruent to UT? Check. Is RU congruent to ST? Check. Some of you might want to say that you have more information, but more information is fine. It's just less information that would have been a problem. It's okay to be more than a parallelogram. You just can't be less than one. So yes, RUTS is a parallelogram. So first on number 16, we have to draw the quadrilateral. Not the quadrilateral. Oh yeah, it is a quadrilateral. It's not a parallelogram first. It's our job to make it into a parallelogram. All right, on number 16, we have angle A. We have angle D. We have AB. And we have CD. Is this going to be a system of equations or not a system of equations? It's not going to be a system of equations, which is great news because the y's are independent of the x's. We can solve for these separately. Let's go ahead and do y's first. We know if we want to force this to be a parallelogram that we need opposite sides to be congruent. So 4y plus 6 equals 6y minus 10. 16 equals 2y. Y is 8. That's dandy. Y is 8. Now, if we force angle A to be supplementary with angle D, if we force this to be supplementary with this, then we will have a set of parallel lines. And so this will fulfill number 5 on our checklist that says one pair of opposite sides is both parallel and congruent. So we are allowed to do that. And so on this one we would say 2x plus x. 3x minus 65 equals 180. 3 okay with this? 180 plus 65 divided by 3. That is a repeating decimal, so we're not going to put 81.7 as our answer. We're going to do math, enter, enter, and we get 245/3. So, luckily it wasn't a system, we just had to treat the sides and the angles separately. Before we move on to rectangle, rhombus, square, we're going to do a couple of the ones from yesterday proving parallelograms. So, if you had this information, is it enough to determine that a quadrilateral is a parallelogram? So I give you a quadrilateral, and the diagonals are congruent. Is it a parallelogram? Yes or no? So yesterday you got a checklist. You got a checklist of 5 things you can check. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. What was the next one? Diagonals bisect each other. Or one pair of opposite sides is both parallel and congruent. Diagonals being congruent was not on the list, right? So I could draw a shape, and this is 7, and then this is 7, and I could connect the dots, and that would definitely not be a parallelogram. So that one would be no. Let's see if the sound will come up. Nope, sound isn't working right now. Okay. Is this enough information to determine that the quadrilateral is a parallelogram? What do you think? Can we add anything to our picture? That's what we always ask ourselves first. Can't add anything. That's just saying that vertical angles are congruent, right? You could have vertical angles in any shape. So this one would also be a no. Oh, there's the sound. Ding. Okay. That one is a no as well. What about this one? Enough information to determine if it is a parallelogram. Wow, lots of yeses. So those who are struggling with this, when you see alternate interior angles, you need to outline the letter Z. This is the letter Z. Outline the letter Z, and you will know which sides are parallel. Alternate interior angles being congruent means you have 2 parallel sides. And now that I outline the letter Z, I know which sides are parallel. This side is parallel to this side. So now I have both pairs of opposite sides parallel, and so yes, that would be a parallelogram. Good job. Last one. Is this enough information to determine that the quadrilateral is a parallelogram? One diagonal is bisected. One pair of opposite sides is congruent. So you always ask yourself, can you add anything to your picture? Can you add anything to your picture? Alternate interior angles? But there's no arcs on them. You can't just put arcs on them. So the diagonals are not bisecting each other. Yes, you could add vertical angles. You could. If you're trying to prove that these 2 triangles are congruent, triangle 1 and triangle 2, except you have angle side side, that doesn't prove anything. So Victor, you're saying that it is a parallelogram? Tell me what you added to your picture. Okay, Victor, you were talking about 2 separate triangles. So just because in this triangle I have a double tick mark doesn't mean that angle number 3 is going to be equal to angle number 4 because we're in 2 separate triangles. I agree with you. If I was in the same triangle and I had double tick mark and double tick mark, that I could put an arc and an arc. But as soon as you're in a separate triangle, all bets are called off. You cannot add arcs across from the tick marks because you're in 2 separate triangles. Okay? So, y'all were right. Ooh, if you said no, that is not enough information. Close, but no cigar. Sorry. All right. Let's start into today's lesson. Let's move past plain old parallelograms and let's move further down our family tree. We're going to look at rectangle, rhombus, and squares, all 3 of those today. It's very important to remember how the family tree works. In the family tree, a shape is himself and everything above it. So if you're a rhombus, you're a parallelogram, and you're a quadrilateral. If you're a square, you're a rectangle, you're a rhombus, you're a parallelogram, and you're a quadrilateral. You are the shape you are and everything above it. Okay? So how many properties is a rectangle going to have? 7. 5 plus 2. Technically, if you take the property from quadrilaterals that the angles add up to 360, maybe you could even say it has 8. But the numbered properties on the family tree would be 7. Okay? Rectangles. They're everywhere. Picture frames, watches, placemats, cereal boxes, iPods, your cell phone. Yeah, everywhere. So, the properties of a rectangle, we already know that he inherits, just like a son might inherit traits from a father, he's going to inherit all the traits from his father, from the parallelogram. So in a rectangle, all of these things are true. All of them are true in a rectangle. So don't forget about those. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, touchdown, and diagonals bisect each other. Okay? So, what do you think the definition of a rectangle is, and it's also property number 1? Look at this, look at the figure. A shape. Okay. A rectangle is a parallelogram with 4 right angles. So that is property number 1. Very good. All angles are 90. It has 4 right angles. So that's property, oops, there we go. Property number 1 on your family tree. A rectangle has 4 right angles. What's property number 2 looking at the figure? What am I trying to show? Oh no, you're going way too deep. There we go, Chloe. The diagonals are the same length. In a parallelogram, they're not the same length. In a rectangle, the diagonals are congruent. The same length, 12 and 12. So some people were saying the diagonals bisect each other. Well, that's a property of a parallelogram. It already has that property. Or that opposite sides are congruent. That's an old one. That's from parallelograms. This is a new one. I call them bonus properties. And only a rectangle gets them. A rhombus doesn't. All right, let's move on to rhombus. We have jewelry. We have the headlight on this car right here. You see the headlight, the rhombus in the headlight? The tail light, I'm sorry. The tail light. A rhombus, get it? Ha ha ha. Rhombus. Okay. So, what is the definition of a rhombus? It is a parallelogram with 4 congruent sides. That is also property number 1 for a rhombus. There you go. All sides congruent. Avi wants to call it a diamond, except it's a rhombus. So a rhombus, I like to think of it as a square leaning over. A square leaning over. 4 congruent sides. What do you think the next property is based off of this picture? What's behind my fading out rectangle? Oh, good point, Avi. They call it a baseball diamond, not a baseball rhombus. I'm pretty sure a baseball diamond is actually a square. Look it up. Diagonals make right angles. Say it better than that. Twinkle, twinkle, little rhombus. Oh, man. Come on, guys. Say it better than that. Diagonals are... Oh, goodness. There you go, Victor. The diagonals are perpendicular. So, bonus property number 1, all sides are congruent. Bonus property number 2, the diagonals are perpendicular. Do you notice how we have right triangles now? We are going to be doing lots of Pythagorean theorem when we have right triangles. Maybe even some 30, 60, 90, 45, 45, 90. And what do you think the last property is based off of the picture? A rhombus is special. He gets 3 bonus properties. Good. Chloe was the first one. The diagonals bisect the opposite angles. You probably don't even need to put opposite. You're right. The diagonals bisect the angles, period. All of the angles get bisected by the diagonals. But remember, left over from parallelograms, opposite angles are still congruent. So the opposite angles are congruent, but in a rhombus, they also get bisected. The area of a square and squish it a little. Oh my gosh. Do you want to know the area formula for a rhombus? You want me to give it away? The area formula is diagonal 1 times diagonal 2 divided by 2. It's really cool. I'll show y'all later where it comes from. Okay, last one is squares. Some pictures of squares. Really kind of random. U-turn sign. Okay, what is the definition of a square? It is a parallelogram that is both a rectangle and a rhombus. So it's a parallelogram with 4 right angles and 4 congruent sides. Quan, you could also find the area of a rhombus by doing base times height. No, you would not times 2. Half base height times 2? Why would you half it and then times 2? It's just base times height. You can find the area of a rhombus base times height. Yeah. Because a rhombus is a parallelogram, and that's the area formula of a parallelogram. All right, so a square gets all 10 properties. We're not going to list the properties of a square because it's the ones of the rectangle, the rhombus, and the parallelogram. Of a pineapple? Oh my gosh. All right, please copy this whole rhombus down in your notes. It's rhombus math. I had fun with 4-letter words. Find the missing angle measurements. What's cool about a rhombus that doesn't work in a parallelogram is that when you know one of the little angles, you know all 8 of the angles. So let's see if you can do it without my help. Rhombus. Ready to tackle this rhombus? All right, so like I said, when you know one angle, you know all angles. Every time you don't know how to start a problem, you take a look at your family tree. You look at a property. One of the bonus properties of a rhombus was that the diagonals bisect the angles. So I'm going to go ahead and run with this 22. I'm going to run with it. Ready? 22, 22, 22, 22. Because the opposite angles are congruent, but the diagonals also bisect the angles. You can't even see that because I wrote on top of the numbers. Sorry. So each of those angles is 22 degrees. Now I'm stuck. So now I'm going to go back to my family tree. I'm going to look at what the other properties are. One of the other bonus properties of a rhombus is that the diagonals are perpendicular. So now I know all 4 of those angles are 90. 90, 90, 90, 90. Now I have 4 congruent right triangles. So I know to find the measure of one of the acute angles in a right triangle that I can just subtract the angle from 90. So I'll subtract it from 90. We'll get 68, right? And then since the angle is bisected, 68, 68, 68, 68. So that is how a rhombus works. You know one, you know all. Next problem. Rectangle rock. RK is 3, RC is 9. Find the perimeter of rock. Go ahead and try it. Okay, let's label our picture. RK is 3 and RC is 9. The thing about a rectangle is that it is a parallelogram with 4 right angles. So I know that this is a right angle. We are no longer doing quadrilaterals. We are now working with right triangles. So look at triangle RKC and notice that it's a right triangle. You know the hypotenuse and you know the leg. So you're going to do some Pythagorean theorem. 9 squared minus 3 squared. And you're going to get 72. You take the square root of 72, and then you realize that that's not a perfect square, so you have to factor tree it. Now, remember that you may factor tree by hand, or you're allowed to go to y equals, and you can put 72 divided by x squared, and look at your table. All right, so for KC, when you simplify that, you will get 6 root 2. And now to find the perimeter, you add up the integers, 3 plus 3. And then you add up the irrational numbers, the radicals, 6 root 2 plus 6 root 2. So we're using our properties like all the angles are right angles, and then our good old Pythagorean theorem to find the perimeter. All right? Next one, we still have rectangle rock, but now we're going to deal with angles. I'm going to solve this one because I'm noticing we're running out of time. ROK is 49. Find the missing angles. Now, one thing that's really important, are you all listening? Because this is cool about a rectangle. Not only do the diagonals bisect each other, but the diagonals are congruent. So if you take two things that are congruent and you cut them both in half, you're going to get 4 equal parts. Because if you take 10 and cut it in half, you get 5 and 5. If you take 10 and you cut it in half, you get 5 and 5. So in a rectangle and in a square, all of these segments are congruent. That is wonderful because that gives us isosceles triangles. They're not all congruent isosceles triangles, but triangle 1 matches triangle 2, and triangle 3 matches triangle 4. So now that I know those are isosceles triangles, and they will be every time in a rectangle, I can use base angle property. If this is 49 in an isosceles triangle, then this one is 49. If those two are 49, I can add them up and subtract from 180. And this angle would be 82. To find this one, we would do 90 minus 49. So that would give us our 41, since we know a rectangle has 4 right angles. And then we are done. We know the rest of the angles. 41, 41, 41, 41. And then we can use kind of a mirror image symmetry, 49, 49 on there. So that's how a rectangle works with our awesome isosceles triangles inside. Let's do a square. Square LMNO. So you can know one side of a square and really know a lot of things about the square. We know that every property you can imagine, all 10 of them, is true for a square. So pretty much in a square, if you think it's true, it's true. So do the diagonals bisect the angles? Yeah, they do. Are all sides congruent? Yeah, they are. So in a square, when you draw the diagonal, we know we have 4 right angles, and we know the diagonals bisect the angles. So in a square, you're always going to have some nice 45, 45, 90 triangles. So we can now find the length of LN using our handy dandy trick. X root 2, 12, 12, 12 root 2. So the perimeter of LNO would be 24 plus 12 root 2. The perimeter of this triangle was what the problem was asking for. Okay. Let's go through this, true or false, but let me just say, you did not get much exposure. You only got to see pretty much one example of each shape. You got to see 2 for one of them. But anyways, you need to do your practice this weekend, the one called special parallelograms. The special parallelograms are rectangles, rhombi, and squares, by the way. You need to do that practice so that when you come on Monday, you're ready to move on to trapezoids, okay? You really need to do your homework. All right, so remember how the family tree works. The shape is itself, and the shape is everything above it, okay? All squares are rectangles, true or false? Ding! True. Because a square is a square, and he's everything above it. All squares are rectangles. Some rhombi are rectangles. This one's tricky. Some rhombi are rectangles. Now, what if a rhombus is a square? What if a rhombus gets promoted to a square? Would he then be a rectangle? Yeah, he would. So some rhombi are rectangles. Which rhombi are rectangles? The ones that are squares. How about that for blowing your mind? Some rhombi are rectangles because some rhombi are squares. Whoa. Okay, next one. all parallelograms are rhombi. Not all parallelograms get promoted to becoming a rhombus. A rhombus is more special than a parallelogram. Some rectangles are squares. Some rectangles go on to become a square. Some rectangles get promoted. True. I hope that makes sense. I have another analogy, although it's not a foolproof analogy. If you need to go ahead and go. Okay? I just think if this makes sense to you, it's kind of neat, but it's not a foolproof analogy, just remember. Because some people struggle with these always, sometimes never ones. So, you could think of quadrilaterals as the human race. And then some humans are U.S. citizens, right? So some quadrilaterals are parallelograms. Some humans are U.S. citizens. And then you can break it down into like people who are over 35. Are all U.S. citizens over 35? Well, no. Are all parallelograms rectangles? No. But some of them are. And then you can have El Presidente, the square. And a square would be everything above. The president would be over 35, would receive the majority of votes in a presidential election, would be a U.S. citizen, and would be a human. Hopefully. Right? So if I asked these, it might make more sense to you. All squares are rectangles. So all presidents are over 35. Well, it says in the Constitution that they have to be. So that would be true. Some rhombi are rectangles. That's kind of the weird ones. Well, the rhombi who become the president, they would definitely be over 35. So some of those would be rectangles. All parallelograms are rhombi. All U.S. citizens win an election. Well, no, not all U.S. citizens win an election. Some rectangles are squares. Some people over the age of 35 become the president. Well, not very many, but some. So I don't know if you like the analogy, but if it helps, that's great. All right, like I said, do your homework. See you Monday.